Okay, today let's look at calculation of formal charge using this formula. Number of valence electron minus number of lone pair electron minus half number of bonding electron. Valence electron are the number of electron at the atom shell of an atom element. Number of lone pair electron. Lone pair electrons are electrons that aren't participating in bonding, and bonding electrons are electrons that actually participate to form a bond, because for one bond to form we need two electrons. Now first we have to draw the Lewis structure of the molecule, and then using the formula we calculate each formal charge for each atom, and then we add them together to get the overall charge of the molecule. Now the formal charge of an ionic compound, when calculated, is actually equal to the sign on the ionic compound, and the formal charge of a neutral compound actually equals to 0. Now let's calculate that for cyanide and sulfur. First we have to draw the Lewis structure as the step implied. So if you don't know how to draw the Lewis structure, request for my previous video and it shall be uploaded in the platform to enable you learn how to draw the Lewis structure, because you need the Lewis structure to be able to calculate the formal charge. So let's make use of the formula and calculate the formal charge for carbon and then for nitrogen. So having written this down, told us that we could actually get the valence electron by knowing the group in which element is actually found. So carbon is in group 4 and hence it has 4 valence electron. So all the elements in group 1 actually have 1 valence electron. Likewise group 2, 2 valence electron. Group 3 down to group 0. So the valence electron for carbon is 4. Minus number of lone pair electron. It has 2 electrons that is not participating in the bonding. Then half number of electron. Now I said earlier that we need 2 electrons to form a bond. So if we have 3 bonds, we invariably mean that we have 6 electrons. So if we are calculated, we're supposed to have minus 1. Now the formal charge for nitrogen. So let's go straight to the formula and put it in the figure. Nitrogen actually has 5 valence electron because it's in group 5. It also has 2 lone pair of electron, and then because it's also connected to 3 bond, then it has 6, and this is equal to 0. Then we have to sum it up. So minus 1 plus 0 is equals to minus 1. This is why we have a minus sign over here. Now let's look at the next example. Now this is SO2. Here we have so this is the Lewis structure of SO2. Following the same formula, let's calculate the formal charge for sulfur. Now sulfur is in group 6, and hence, just as the formula, number of valence electron, group 6 minus number of lone pair electron. On sulfur we have 2 electrons, minus half number of bonding electron. Sulfur actually has 4 bonds, and if each bond has 2 electrons, that means we have 8 electrons. Sorry, there was actually an error in our structure. 8, this is supposed to be 6, so over here sulfur actually has triple bond, not 4. So over here we have 2, right? So this isn't part of it. Let's clean that up. So having erased that, the number of bonding electron is actually, since it has 3 times 2 electrons each will give you 6. Okay, so let's do some calculator work. So that will give us plus 1. Now let's look at the oxygen at the left hand side. The number of valence electron is 6 because it's in group 6, minus the number of lone per electron over here in oxygen is actually 4. We have 1, 2, 3, 4, minus the number of bonding electron. It has 2, so it has 4 electrons because each has 2. So our answer is going to be 0. Now let's check up the oxygen at the right hand. This actually has 6 valence electron and has lone pair is 2, 4, 6. Since it has one bond, it has only 2 electrons in it, and this would give us -1. So we're going to sum them up. When we sum them up, we're supposed to have 0 plus 1 minus 1. So we ignoring the 0. It's actually supposed to give us 0. So this is why we have the neutral SO2. So I'm going to be uploading another video on a more simpler formula that we could use to still calculate formal charge. Always remember to put these formulas to use, because if you don't make use of them, you're going to lose them. So practice is actually going to lead to your perfection. You need to get used to them. You need to solve more questions. I'm going to be uploading questions that is going to enable us to practice these formulas and this lecture, and also the solution thereafter. So we're going to calculate the formal charge of carbon monoxide, carbon dioxide, and SO3 to minus experience and difficulty. I want to see it below the video after the video has been uploaded. The answers or the solutions I will upload subsequently.